Um, this is Plug. This is the Portland Linux Unix group. We've been meeting for a long, long time. There are a few new faces here, so welcome to everybody. We have a speaker tonight, which is good. This is Caleb Phillips. He's a graduate of Portland State University. He and I have known each other for quite a while, since about 2006 or so. We were fellow volunteers at Personal Telco Project, and then we did a fun study of the Metrify network. Does anybody remember the Metrify network?
I remember your presentation about it.
Yeah.
You found that it didn't really work.
The number that I remember is 2 in a billion, but that was the probability that they were meeting their performance threshold.
And it was not that long after 9/11, and you were walking around town with a very strange.
Yes, we had a yes. That was fun. I don't remember ever getting stopped or anything. We did. We had one. So we did a random sample, and we went around and measured the places that we had. There was one just outside the Central Precinct downtown.
Oh, I don't remember.
We weren't actually sitting on a police car hood, but we were pretty close by. Yeah, so anyway, we had a good time. I like to say I got him into graduate school, but, you know, he probably could have gotten it anyway. Anyway, he's going to talk tonight about, well, wait a minute, before we go through the full introduction, what I have to say every time is that we need speakers. I don't really have a speaker for next month, although I have a possible or a wobbly backup speaker, but we'd really like somebody fresh and new. So if anybody has ideas about things they'd like to talk about, contact me, and I'll get you hooked up. But again, this month we have a speaker, and he's about to speak. He's going to talk about a thing called Meshtastic. So,
Yeah, I'll say about preparing a talk that, I think Russell sort of said, "Hey, do you want to give a talk?" And I was like, "Oh gosh, what does Russell want me to do now?" And then I kind of started making some slides and kind of had fun with it. So if there's something you're interested in, you might actually enjoy putting together a talk if you start on it. So it can feel like just another thing, but I actually had fun putting this together. I guess before I dive in and start talking about this, I'd just like to see a show of hands who's familiar with Meshtastic. Oh, just a couple people, okay, and how many, I suppose, of those people are operating a node or have a node? Okay, great. So we're starting from scratch pretty much in the room, which is good. The slides should work for that, and I think we'll be able to cover a lot of material. I'm not going to go super into the weeds. We're not going to be like tearing apart the source code or anything like that. I'm going to kind of approach it from the perspective of maybe you want to play around with this and you're just trying to figure out what it's all about. So that's what we're going to try to do today. Sound good? All right. Okay, so Russell gave a little bit of an introduction, but I like to kind of say who I am, so you know who's talking at you for the next however many minutes. I grew up here in Portland. If I understand where I am, 5 blocks that way actually, over on 11th and Columbia, so right by the PSU campus. And I ended up going to school here and Portland Community College as well. And then I wandered off to Colorado for a while, almost 20 years. I did my graduate work there. So I worked on wireless networks and geostatistics at the University of Colorado. So I actually worked on a PhD topic that had some similarities to what Russell was talking about. So I was interested in how to create an accurate map of a city's wireless network. And so that kind of topic kept me busy for about 5 years, and then I wandered off to other things. So these days I'm a data scientist at a government lab. I still remarkably have a job since we know the world that we live in. It's interesting, and I actually do research on renewable energy technology now. So Maybe even more remarkable that I still have a job. But it's good work and it's interesting, but my employer does not like me to name the lab in public settings, but it's in Golden, Colorado. And here tax dollars are hard at work. They're looking at renewable energy technologies. I'm also adjunct at the University of Colorado. I used to teach there, but I live here now, so I don't really teach there so much. I've worked with some nonprofits, personal telco. I started a couple nonprofits that have to do with food recovery. If you're interested in food or food recovery, I could talk about that too, but that's not why we're here. So let's talk about electrons and moving them around. So I sort of wanted to start here because I think it was at the last plug talk I was at that Bart Massey was giving a talk. And I think at the time he was trying to do, some of you probably know him, right? He's
Yeah.
a PSU professor who I'm sure has joined these meetings sometimes. But at that time, he was trying to build like a radio front end in Haskell or something. It was some wild experiment. I don't know why anybody would want to do that, but it was fun and hard, and so why not? But I remember his talk still to this day, and he started out by saying, okay, look, wireless networks and wireless radios are these complicated things, but really all we're going to do is we're going to slosh around some electrons on this piece of metal over here, and then magically some electrons are going to slosh around on that piece of metal over there, and we're going to try to do something with that concept. Sorry, I just thought that was sort of an appealing way to start, so I want to start there too. I'll go over a few concepts here that will be useful as we go through the rest of the material. So modulation. That's basically how we're going to decide to put bits on that antenna, on that piece of metal, sort of the agreement on how we're going to do that. Signal to noise ratio and signal to interference and noise ratio is the way we communicate about how well the signal is received on the other side. Protocols are like how we decide to organize those bits so that other people can understand us, right? Mesh networking is the idea that we can take a bunch of devices and cooperate to move information further than any two nodes could communicate amongst themselves. And then IoT networking is this idea that like maybe everything should be on the internet. It stands for Internet of Things, and it's not a new concept at this point, so I'm sure you all have heard about it, but if you're wondering why your washing machine is on the internet, it's probably because somebody at some company pitched to their boss, this IoT thing, that's what we need to do, and then now your washing machine is on the internet. So, and feel free to interrupt me with questions, I don't mind, keep it casual. So I'll give you a little bit of my perspective as somebody who sort of worked in the academic realm of wireless networking. So like around 2010, there were a bunch of people trying to do this thing called sensor networking, and it was kind of similar to what we're talking about tonight. The idea is, hey, we want to move information over a long distance, but we want to do it with small, low-power devices that can cooperate to send it. And so there are all these conferences and journals, and people are publishing all these papers about this stuff. But the thing is, it just didn't work at that time anyway, because the devices were unreliable. They had poor transmit power. The batteries were not very good. The solar panels were expensive and they were inefficient. The modulation schemes that we had, they kind of only worked okay, so we couldn't get the bits very far, and the error rates were high. And there's no consensus on protocols. Like every grad student made their own protocol, and so nobody used the same thing. And so, at this time, I sort of looked at all this stuff, and a lot of us did, and said, what are you guys doing? Like, this is just a mess. It doesn't work. Well, some things have changed in 10 years, for good and bad, I suppose. But one thing that has gotten better is this idea of using small, low-power devices to move information over a distance. And I think that this is in part due to investments that have been made in IoT networking. So your washing machine being on the internet is a good thing in this regard because it got companies to invest in this technology. It created an economy of scale. It reduced the price of these devices. More people could use them and experiment with them, and then we had some sort of technology emerge that's actually like useful to do something fun with. So these are the things that I think have changed. The The devices have gotten increasingly reliable and cheap. The modulation schemes are better. We'll talk about that a little bit. The batteries have gotten better, and goodness, are they cheap these days? It's amazing, at least for now. I don't know what the status is on the tariffs. The solar panels have also gotten really cheap and efficient as well, which is sweet. And we have mature standards and common protocols. So that's a lot to get done in 10 years, which is pretty cool. Meshtastic sort of emerges out of this. So what was going on in 2020? Well, a lot of things, I suppose. But one thing that happened is we have a bunch of nerds with free time. And maybe the nerds want to be outdoors, doing outdoor hobbies. I don't know. Some nerds like to do that. And so, you know, they thought, I'm going to do my outdoor hobby and I'm going to play with radios while I do it. Also, maybe people were more interested in security. Maybe they're increasingly interested in emergency preparedness. And so that led to a focus on this. And also they wanted to spend their money on something to distract them from everything else that was going on in the world. And so it was around this time that Meshtastic emerged. And then you sort of get to something that looks like this. So I have a device here. Looks just like the picture, kind of, except for it has a different antenna on it. And so this is a fully functioning Meshtastic device, which can transmit like messages a mile or more if it's in unobstructed area, which is pretty impressive. And it has a battery life of maybe a week without being charged. So pretty cool. Stop there. Any questions before I go on?
Where does Meshtastic live with respect to things like the Willamette Valley Mesh Network?
I don't know about that.
Okay.
I believe they're using Wi-Fi.
Yes, they are.
Yeah. This is not Wi-Fi.
So different frequency and presumably a different protocol.
Okay.
And that's actually a really good segue. So, so the first thing I'll talk about is that makes this sort of a unique thing is the frequency that it uses. So Wi-Fi, for instance, likes to operate around 2.4 gigahertz or 5.8 gigahertz. Those are chunks of the electromagnetic spectrum that the FCC has said we can all play with as long as we stay under certain transmit power rules. Another chunk of that spectrum is 900 megahertz or 915 megahertz, and that's where Meshtastic operates. What is worth knowing about this, if you're not familiar with this, is basically as you increase the frequency, you can carry more information, but not as far. Right? So it's sort of the higher frequencies interact with materials in the environment more. Lower frequencies sort of go better. That's why your AM radio, you know, they don't only need one transmitter. It works really well. But you might remember a 900 megahertz device that was in your house if you're of a certain age. I certainly remember 900 megahertz telephones. What's important to know is that this thing that the government has done, that the FCC has done, allowing us a sandbox in a few different places in the spectrum, has allowed a lot of innovation. So Wi-Fi came out of this, these funny phones came out of this, all sorts of things have come out of this, and Meshtastic is an example of that.
Aren't you a tertiary user on the 915 megahertz?
Who is a tertiary user?
Meshtastic? They've got to deal with any interference that is given to them by...
That's right. Yeah, so ISM users are not always the primary user on the spectrum that they occupy. There's sometimes a primary user that has preference. Depending on the piece of frequency that you're in, you might have even additional rules, which is like you have to sense, and if the primary user is transmitting, you sort of back off. So this is how the FCC manages to sell the same amount of spectrum to multiple people, basically. Does that answer your question? Okay. Okay, so what is this stuff that we're talking about? So it's an open source embedded application that runs on IoT devices. That's what Meshtastic is. Uses mesh networking to move messages around. You usually connect to this device over Bluetooth. So that's sort of unintuitive to some folks, but you can think of this as like an additional radio for your phone. Kind of think about it that way, because your phone has probably an LTE radio that can communicate with the cell network. It probably has like Wi-Fi radio, can communicate with the Wi-Fi in this building, has Bluetooth radio, so it can communicate with your headphones. Now you can use this 915 megahertz radio that can do Meshtastic as an additional radio on your phone, and it links to your phone with Bluetooth basically. But from your perspective, once it's linked, it's like you just have another radio.
So does that have two radios, or is it sharing the same radio?
It does have two radios, so it has a 915 and that has the Bluetooth, which is 2.4, I believe. Additional humans.
Yes. Okay, start over.
Yeah.
Would it be ever conceivable that, say, that one day they might start including Meshtastic radios in regular phones, like mobile phones, or
I mean,
fit? You have to
yeah.
have a bigger antenna or something?
I could imagine a scenario where you get to the scale where a LoRa radio could be part of LoRa being I'll talk about that, but that's the protocol that Meshtastic uses. I could see that being integrated into maybe some particular phones.
So you could access it via an app on your phone or something?
Yeah.
Just transmit at a different frequency to nearby or not so nearby devices.
Mm-hmm. There are a lot of military applications of some of the underlying technology, and so I don't know much about that, but that speaks to the fact that there's a whole other industry that's interested in this sort of stuff too, and so yeah, I could see it becoming more widespread. Okay, so maybe you care already, and I don't need to convince you that you care about this, but here's why you might care. So if you care about emergency preparedness, like if you're one of these people that thinks about the giant earthquake we're going to eventually have and how complicated that is going to be, if you're the kind of person that thinks that moving electrons through the air is just magic and cool, or if you're somebody who cares about security and private communication and sort of off-grid communication, in any one of those reasons might make this interesting to you. If you think all of these things are interesting, then you're like probably ordering a device right now. And so, I found myself somewhere in here and then felt compelled. So maybe that will be some of you as well.
Which one did you start in?
I care about all of these things for different reasons. I've probably been doing the radio thing the longest, but I actually came into this through the preparedness thing. I was like, I moved back to Oregon, right, as I mentioned before, and I thought, I should put together an emergency disaster kit. Hopefully you all have something, even if it's like a jug of water in the basement. And if you don't, that's the other thing to order right now. And so I was like putting this together, and then being a nerd, I was just like, well, but what are we going to do? All the cell towers are going to be down. How am I going to communicate with my neighbors and my family? And so then I found this. The other thing to know is that critical mass already exists. So folks like Russell and I who've been doing the wireless thing for a while, we have this existential pain of being one of few people trying to do something and there isn't a critical mass. But this is a space where there's already people doing this, and there's enough of them that you can already do cool things. And that, I just can't say what a big deal that is enough, that there are already thousands of people in Portland playing with this, because it means that you can get one of these devices off the shelf, you can plug it in, and you can start communicating with people on the other side of the city, like today. So that's pretty cool. So there's this map at meshmap.net. It's definitely not complete, but it gives you kind of a sense of where some of the long running nodes are in Portland. And this is just like a little experiment that I did. So I took, when I first got my outdoor node set up, I strapped it to my gutter, and then I sort of went around my neighborhood. So I live here in St. John's, and this inner polygon is where I could hear my node with one hop. So basically all of St. John's, if you're familiar with St. John's, I could communicate back to my house with just one device. And then this is sort of the area that I could casually get back to my house with 2 hops. So I was like using someone else's node to get back to my house. So from the perspective of emergency preparedness, $100 device that I strapped to my gutter was effectively giving me the emergency preparedness network that I wanted for at least my neighborhood, like, and a sizable chunk of North Portland, really. So that's pretty cool. Okay, so I'm going to talk a little bit about the tech that makes this work. Anything else on the front matter before we dive into tech? Okay, so under the hood, so Meshtastic is an open source piece of software. It's an application that runs on this device. This device, though, has a proprietary radio that does this thing called LoRa. So LoRa stands for long range, and it was a protocol developed by the person that started Semtech Semiconductor. And so if you go buy one of these devices, they're made in China, and they have a Semtech 915 megahertz radio that implements LoRa. So that part of this is not open source, at least as of yet. It'll also have a Bluetooth radio that's generally made by a company called Nordic, but there are lots of those, and I'm sure that there are some open hardware Bluetooth radios that you could play around with. Basically, LoRa is responsible for, if you sort of look at the stack, Meshtastic is up here running in the application layer. LoRa is the medium access control protocol, so that's like the protocol that determines how the radio interacts with the medium. And it's responsible for the modulation, which again is the agreement on how we're going to put bits on the wire, so to speak, or in this case on the not wire. And then this is just that's the radio channel itself. In addition to Semtech, the other player in this is the LoRa Alliance, which is a consortium of companies that are trying to promote LoRa. And so there are a bunch of companies affiliated with that. Yeah.
So there's this question of unlicensed band in the U.S. in particular, this whatever band this is in, is different than Europe, for example.
Yeah.
Do common devices, you have to pick one, or will they operate on either?
Yeah, it seems like the radio is able to do, I don't know about
The
430,
430, yeah.
but they're able to do a range. The front end is adaptable enough that it can do the range of frequencies, and so it's just a setting in the
Gotcha.
software.
Is that an SDR inside then?
No, I don't believe so.
Sorry, software-defined radio for those who don't know.
Yeah, so I don't know what Semtech is putting in there, but I do not think it's an SDR. If we could figure it out, we could make our own, get on our business. Oh, we're recording. Sorry, Semtech. So the LoRa MAC, so this is how the device communicates with and shares the channel, is roughly based on Aloha. Does anyone know about the Aloha? Oh, I see a nodding of head. Enthusiasm for like 1970s Hawaii. Why not? So the story is that in the 1970s there was a time server at the University of Hawaii on Oahu, and they wanted to synchronize computers on the rest of the islands with the Oahu time server. And so somebody there, I don't know their name, came up with a very simple protocol to communicate that information wirelessly. And how it worked was they would transmit, and if there was an acknowledgement, then okay, good, the message got received. If there was not an acknowledgement, then they would wait a random amount of time, up to some limit, and then retransmit. And so that very simple protocol, medium access control protocol, is very well studied. It's actually built into a lot of things at this point, and Meshtastic uses an Aloha-like protocol. What it does is it has a transmit window, followed I think by 2 receive windows. Is that what I wrote? Yeah, receive for 2 windows. And so it tries to transmit, and then it listens for a while, and if it doesn't hear an acknowledgement, then it randomly waits a little while and it retransmits. So it's effectively Aloha, and a very simple Aloha protocol. You'll pick up a theme here. A lot of the components of this stuff is very simple, which is great because it makes it fun to experiment with and learn about radio. That's a design decision to reduce power consumption, basically. Okay, so the modulation scheme that these guys use is pretty unique. It's something that I guess came out of like military radar, but the idea is that it chirps. That's what people say. So there are lots of different ways you can spread information over the frequency spectrum. And this is spread spectrum techniques, right? You might want to do that for a number of different reasons. Maybe you want to do it because you want to avoid jamming, or maybe you want to do it because you just want to share the channel in an efficient way. How these radios do it is they encode the binary data as a series of up and down chirps. And so an up chirp is a increasing frequency, and a down chirp is a decreasing frequency. And so it's like, I'm not going to make the sounds, but you can imagine if you were going, up and then down, okay, that's 1 and 0, right? And so you can encode the information that way. And that effectively spreads the information over the band. And it creates something that is apparently has decent error recovery characteristics. Is that a question?
Wide band are we talking about?
I can't tell you off the top of my head.
Multiple megahertz?
Yeah,
or-
like,
or-
like
It has to
like
fit
a
in
couple
whatever the
megahertz.
ISM band
Yeah,
is
but the
anyway.
ISM band is fairly wide.
Yeah.
I think it's like 30 or 40 megahertz. Yeah. So I mean, these channels are like a megahertz or half.
Okay, so
Yeah.
it's split into
Yeah.
channels.
Yeah. I
And
have a
what-
waterfall plot later, and you'll have to
what
get
kind
an
of
idea.
bandwidth are we talking about? In terms of bit rate?
Oh, I don't know that either. That's a good question.
It's pretty slow.
Yeah.
Yeah.
I figured.
That's a
Maybe kilobits or something.
When I first reached out to Russell
Yeah, I
about
said
this,
I'm not
he
interested.
said he's not interested if they can't watch cat videos. And-
Exactly.
You can encode cat videos smaller.
Okay, yeah, there you go. There's always a way to get cats through the channel.
Anyone who started on the internet on dial-up,
Yeah, I know. When you see someone like fighting with their
Sorry, that
computer,
part of my brain
you just
is
want
dumped a
to
little bit
translate.
ago.
Yeah. Okay. Was there something else?
No.
No? Okay. So here are the hardware that you get to choose from if you want to get into this. So they're all in China. So LilyGo is in Shenzhen, China, Rack Wireless also in Shenzhen, and Heltec is in Chengdu. And these are examples of what their platforms look like. I've done a fair bit with this Rack Wireless. It's a nice platform because it has all these little daughter boards that you can put on it to change out like the communication appliances that it has, so to speak. It's like a modular platform, basically. Some of these other ones have like built-in displays, like this LilyGo has a display built in, which I haven't really been able to figure out what the value of that is, apart from that it can do a random Bluetooth key, which is like maybe more secure. Have to actually read the Bluetooth key off the device. They all cost about $30. So a lot of people.
Anymore.
Oh, 35, yeah. I mean, they'll be much more eventually, I suppose, or an infinite amount of dollars eventually, maybe.
There's a really popular one now for satellites called Hope and they just make little tiny modules like the Rack Wireless, but they're a little smaller.
Okay.
A little cuter.
And it does okay, cool. So yeah, 30, 35, $40. You can buy into this. It'll be powered with a USB-C cable, and you can sit it next to your desk, next to your window, and all your neighbors' packets will go into a black hole in your house. That's probably not what you really want to do. You'd probably like to put it in a better position spot, but that is, I think, what a lot of people do initially is they drop $30 and they just plug the thing in on their desk and start to play with it, and that's a fine way to start playing with it. You can go, one further, and you can put it in an enclosure. Like this is, a commercial device that comes with an enclosure and a little e-ink display, which again tells me nothing of any value, but it looks cool. You can even get ones that have like a keyboard, so you don't need your phone. You could just, send and receive messages with the keyboard. These guys are like in the $80 to $100 range, sort of pre-built, and then there's this whole ecosystem of printable cases. And so you can, if you have a 3D printer, you can print your own, design your own, I suppose. Or if you don't have a 3D printer, you can certainly buy a case from someone on Etsy who is making a little cottage business right now of printing these cases, and so that's kind of interesting too. So now you're talking about $30 for the device, maybe $10 for a battery, and another $30 if you buy a case from someone on Etsy. So now you're in like a $60 to $70 range versus the $80 to $100 for like a turnkey kind of mass-produced object. And it's fun to build it yourself. Okay, so you go out, you buy a thing, whatever it is. The first thing you're probably going to want to do is flash it. So depending on who you bought it from, it may have come pre-flashed with a Meshtastic firmware, but that Meshtastic firmware is probably out of date. I had an issue with several of my nodes where they just all like bricked themselves. They went into some death loop, and I had to flash them all once I figured out what was going on. So they were just basically running a firmware that had a bug in it. So I would say first thing, update the firmware. Now how you do that is you go to flasher.meshtastic.org. You choose the device that you have. There are pre-built binary firmwares for lots of different devices. Depending on the device you have, somehow this web page can like flash it. I don't really understand how that works. It's sort of scary. With my device, it just gives you a little .bin download that you drop into a USB mass storage device on your computer, and it flashes it. It's very easy. You don't have to like bust out your serial terminal cable or anything. You start soldering stuff.
So what nRF52, that's the processor it's running on, or what processor?
Oh, okay, yeah.
The
So
firmware that you're downloading runs on what?
The firmware that you're downloading runs on an Arduino kind of thing. That's what's coordinating the. It's like an Arduino. I mean, depending on the device, I think they're mostly Arduino platform with the Nordic Bluetooth and the Semtech.
So, honest to God, AVR.
What for the protocol for
The
flashing?
AVR is what an Arduino.
Oh, yeah, I don't know.
It can handle multiple. There's like multiple platforms that it supports.
But these common modules, some of them are AVR based.
Yes.
Yes, I mean, I know that the rack wireless ones are.
nRF52 is an ARC Cortex M0.
Okay.
And you're programming it that, but it's running the Arduino bootloader. And Arduino is just the bootloader. It can run on any different kind of chip.
Yeah, original Arduino.
Yeah, it's not
obviously,
original.
AVR.
Yeah.
Yeah.
But if you go on there, you can see like that flasher will show you, right, when you do that flashing process, it will show you like what device it's detecting. And you can like look through what it's, because like the flasher supports a distinct set of those devices. And like he said, for others you have to like go through this process of putting it on a USB drive, plugging it in,
Right.
and flashing it sort of thing.
Yeah.
And others still, like you have to Meshtastic. You can obviously install it on Linux, like a Linux system, et cetera, et cetera.
Yeah, and this note here is specifically about over-the-air flashing. So, this particular Bluetooth chipset supports an over-the-air flashing, which is really useful once you've like strapped the thing to your roof. Unless you want to run a USB cable like down the gutter. Okay, so good discussion there. I don't know all the details about the hardware. So I'll just walk through a usage example using the phone app. I've taken some screenshots of the phone app. So this is on Android. There's, I suppose, Apple and who knows what else. Android is what I'm using. So basically the first thing you do is you pull up the Meshtastic app on your Android phone, and it's going to let you connect to a device, or you can add a device if there aren't any. So I've given my devices these cute emojis. This is not that uncommon in the Meshtastic world to use emojis for the node names. So you may hate that or love it. I don't know. I think it's kind of cute. Right now I'm not connected to any node, but I could maybe decide to connect to a node. And so I'm going to connect here to this node Sparkle. And it tells me I'm connected. It sort of says that it's getting information from the device when I do that. And then now if I click here on the little people tab, they just changed this interface. It like used to be up there, now it's down here. But you click on the people tab, you can see your node that you're connected to, but also all the other things. And so this is like, I took a screenshot of my phone while I was sitting in my house. And so this is just what my node Sparkle is seeing. It's like, Shrimp Mobile and Cat Repeater. So this is what's out there. These are your neighbors. It's telling you some information about their nodes, actually. So like this GHC base station, my node is hearing from four hops away. So my node received a packet from that device 4 hops away, and it registered it, and it put it at the top of the list because it most recently heard a packet from that base station. Cat Repeater's 5 hops away. This one's 3 hops away. Shrimp Mobile, which I think is on someone's car, is 5 hops away.
And that says 14.2 and 29.2 kilometers.
Yeah, that is presumably like a great circle distance. So one of the things you can do is decide to share your location. And some of these devices have either GPS built in, or you can add a little GPS receiver. I would say that besides changing the Bluetooth pin, maybe one of the first things you should do when you get this thing is like at least make a decision about whether you want to share your location. The other tab here is this map tab, and so it will show you, like, these are some of the nodes that my node had recently heard packets from. So sort of all over Portland and even up into the wilds of Washington State. And out here in Sandy and these sorts of things. So how is it hearing from these guys? That's a good question.
Yeah.
Canada's high.
Yeah, I haven't given you enough information to answer that, so it's a bit of a trick question, but maybe somebody knows.
Isn't it just hopping from someone else?
Yeah, I mean, it's entirely possible. Like
On
this
the
one in
internet.
Sandy may be on top of a mountain, or there may be some other hops that I'm not seeing. The other thing is it can be on the internet. So one of the things people do is they use MQQT, which is a way of tunneling packets through the internet. And so using that protocol, you can take 2 devices and you can sort of bridge them through the internet. Now, this is sort of fun for the radio people. It's not fun for the emergency preparedness people. And so, the emergency people maybe get a little grumpy about that. But that's fine. All those people are going to be in trouble. They can't communicate anyway unless
They're going to be fishing the water out of their basement.
That's right. Yeah. Okay.
So
Yeah.
it's common for nodes to be doing some sort of, the protocol includes some sort of broadcast, or your node can echo
That's
a
right.
broadcast packet somehow.
Yeah, so that's a really good question. I don't think I have a slide on that. So like, how does the network topology and routing work? It's really dumb, but it manages to work. So what it does is your node listens, during those receive windows, and if it hears a packet, it checks a little database, a little file that it keeps of all the packets that it's heard in some time window, and if it's seen that packet before, it just drops it. If it hasn't seen that packet before, then there's a hop limit field. It decrements that. If that would go below 0, it discards it. If it's 0 or above, it just retransmits it. So basically, you send a message out, and every node in Portland is going to transmit your message at least once. So it's not a very effective use of the channel, but it's simple and it works. Yeah.
So in the case of event with a large number of these, what would be critical mass before there's breakdown?
Yeah, when does the channel start filling up? We're already starting to get to that point in some parts of central Portland. And so I'll talk about the different channels that people can use, but some users have already started to switch to another like modulation setting that is better for denser networks, because the default is for sparse networks. They want it to work out of the box. They're not expecting.
Well, it's also in the early stages of this, and that's a growing pain they have to work through eventually.
That's right. Yep. But the way I look at it, being someone who was attracted to this originally for emergency preparedness, is, I'm thinking about a scenario. I don't want to use this to communicate with all my buds all the time. Like, I just want it to work if something, goes sideways. And so in that scenario, it just needs to kind of work well enough to be better than nothing.
Or kind of like, the story about the bear chasing you. You don't have to be faster than the bear, you just have to be faster than the next slower person.
I hope we don't have bears
so what
in
you
the
want,
tsunami.
What you want is a battery that outlasts all the other clouds.
That's right. So we'll talk about that. It's called harnessing the power of the flaming orb. Because probably we won't have our sun implode at the same time as we have
We have the sun implode. We have much bigger problems.
Yeah, exactly. Okay, so if you go into settings on in here, which I think you click on a hamburger somewhere to get into here, there are 3 settings that I'll tell you might want to think about changing. So the first is change your Bluetooth key, because by default it's like 1, 2, 3, 4, 5, and so you don't want to strap that to your roof. That would be a funny thing for your neighbor, if you have the right kind of neighbor.
I am that right kind of neighbor.
Yeah, see, there you go. It's like, why is my printer just printing? So what is this over my Bluetooth speaker? So hop limit is another thing you might want to change. I mentioned already what that is. The default is 3, so that means that that your packet is going to move at most sort of 3 hops, if you think about it, which should be good enough to kind of get everywhere that you need to go. If you're really on the edge of the network, you might want to increase that so you can get your packets further. And so, like, I'm in St. John's. I am on the edge of the network, and so I bump mine up a little bit because, like, I've been trying to communicate with someone in Beaverton, and it's kind of amazing. Every once in a while, a packet goes through, but they don't go through all the time. And in part, it's because we're right at the edge of what is possible with this. Yeah.
What is the lag for, let's say you send a message, what's the threshold before which it will never get there? Like, because there could be some low power situations where something can hang out for somewhere for a little bit, and then when it finally has access, then it sends it off.
Yeah. Well, I mean, one thing to know is that acknowledgements are not broadcast in the same way that messages are. So you never really get to know if your intended destination received your message. All you know is that someone heard it and rebroadcast it. So that's kind of a part of an answer to your question. The rest of it is like, yeah, it's just going to be rebroadcast until the hop count goes to 0, and then it's gone. So it's a bit ephemeral, the communication here. You don't have a great deal of certainty that your message was received.
Right. But what is the longest time it could take to get somewhere before it would
Oh,
never?
I mean, yeah, it's like microseconds. It
Oh.
really shouldn't take that long, just because unless the channel is super congested, but then all your packets are going to fail anyway. You need to change the frequency, as Russell pointed out earlier. You need to select the United States frequency unless you want to be a pirate and hang out on like the EU band. Don't do that. And then long fast. So I'll talk about that. So modem presets. So I mentioned earlier the default modem preset is modulation preset is long fast. Each one of these corresponds to some setting of like channel widths and lengths for those chirps in a table somewhere. And I couldn't find that table when I was preparing this talk, but this is sort of the colloquial description of what these are. So your shorter, faster modulation settings are good for like really small, dense meshes, and your longer, slower ones are better for like, you know, sparse, rural sorts of situations. Long fast is what it's set to by default. Some people in Portland are starting to use medium fast because of density, as I mentioned.
Do the receivers look on both, or are they, you must use one modulation?
Yeah, they're they're orthogonal in some sense. So,
Okay.
So yeah, if you're talking on long fast, no one on medium fast is going to ever hear you. And the waterfall plot sort of demonstrates that because they use different parts of that 915 megahertz frequency spectrum. So this is like what a short fast packet looks like. It's just like a little blip. And here's a medium fast, and here's the default long fast, how it spreads it over both time and frequency. So if you're not familiar with the waterfall plot, this is time, and that's frequency.
You can almost read long fast.
Yeah, we see the little squiggle inside.
Yeah, you can see the chirps
Yeah.
in there, kind of. Yeah, totally. It's pretty long. You know, it's trying to have a low error rate. Okay, I already mentioned the hop count. The role. So this is another thing where I've been having, you know, there's documentation, but sometimes you just have to look in the firmware to figure out what's going on with this. I mean, the documentation is pretty good, but some of the stuff in the weeds is not really super well documented. So again, the colloquial understanding is you have these different roles. By default, your radio will be configured to client, and that means it will behave like a normal cooperative node. It will like rebroadcast other people's packets, and it will send yours. If you set it to router or repeater because you think you're cool and you put it on your roof, people say that that's bad. You're going to sort of get too many packets to go through your node, and it's going to be inefficient. Now, I don't understand through what mechanism that actually happens as much as I've looked into it, which is not a ton. But anyway, this is the idea, is that you're only meant to use router or repeater if, like, you know, you're on the top of the West Hills. Otherwise, client will do the job, and then there's some special roles that prioritize certain kinds of messages. Like one thing you can do is you could build a GPS tracker with a Meshtastic device. There's somebody in the community that's making dog collars. I mean, why not? It builds a mesh, and I can find my dog. So anyway, you could maybe set that one to tracker. Okay, here's how you would communicate using the app. So by default, you have access to a channel that's called long fast if you're on long fast, and it is in fact encrypted. All the messages are encrypted, but they're encrypted with a key that everybody has. And so it's sort of, you know, it's a public channel. This is what you would see if you got on there. So you see a lot of people saying, range test, and then this person says, oh, I received you in Vancouver, and I received you in Gresham, and, you know, oh, I'm going to sleep. People put oddly personal things on there. And something about going to Crater Lake. Okay, good for you. So, you know, you can kind of see the chatter. It's quite nice. It's just a lot of people doing range tests, talking about the weather, that sort of thing. If you wanted to create a separate channel to communicate with, you know, your humans, and you wanted to encrypt it in a way that only they could decrypt, what you can do is you can create a pre-shared key. So like at a personal telco meeting, I made this one PTP mesh, and so it has a pre-shared key, and then I can share that with people, and you can share it one of two ways. You can either give them this QR code, or you can give them this magic link, but it's basically, I think, an AES key that they will use to encrypt the messages. So the next step beyond this is the building a solar-powered node. If you think that's fun, and I thought it was pretty fun. I built up some of these. You can get a set of like batteries and wiring and a solar panel and antenna and an enclosure for surprisingly cheap, like about 120 bucks, like not that much more than some of the off-the-shelf devices. They all sort of have about the same configuration. You've got your, I actually don't know what that is, but you basically have your radio, and then you have some connection to the solar panel. That's all these red wires, I guess. It must be some kind of charge
PoE,
control.
it looks like PoE.
Oh, PoE, yeah. Why would they have PoE in
I
a
don't
solar
know.
panel? I don't know. Anyway, you can find these pictures online, and you can figure out what people did.
Well,
Yeah.
I think one of them was a USB antenna, or a Bluetooth antenna on there.
Oh yeah, so a lot of these come with little PCB, like right there. That's probably the PCB Bluetooth antenna that you can just stick to the inside of the case, and then that's like an end connector for the 915 megahertz, the LoRa connector on the top. Or you can see it better here. I'll show you an example in a minute. This eye chart is just meant for posterity. If you want to build one of these things, this is the set of parts I use to build my outdoor node. Let's show that thing. So you can take your node on the bus. TriMet doesn't mind.
It seemed weirder.
Yeah, they have definitely seen weirder. Yeah, so this is one of my nodes. I guess I've built like 3 or 4 of them now because I've been sort of playing around with it. The clearance is a little tight on these things. But yeah, so there it is. You have just these little LiPo batteries. They connect to this rack WISP block. I initially bought these little standoffs from some guy on Etsy because he was like laser cutting them and it looked nice and clean, but on my subsequent ones I just use zip ties. It works great. I put a little breather plug in here in case this thing gets really hot and it wants to like let a little gas out and hopefully not pop the seals. This is the connector out to my 915 megahertz 5 dBi Omni, so that's omnidirectional antenna, which you'll notice is mounted down. That's nice. End connectors, which is the kind of connector this is, are waterproof, but still, we live in a rainy place. You mount it down, water's not going to really try to find its way up in there too often. And it works pretty much just as good. If there's a down tilt, it's negligible. 45-degree solar panel, which is like pretty good for the medium day. I think that's correct for this latitude for winter, which is when you care, right? These brackets are 3D printed from a print that's available online. I don't have a 3D printer, but everyone who doesn't have a 3D printer knows someone who does at this point. So you just like call up your cousin and say, hey, here's the STL. The enclosure is super cheap. It comes from Amazon. It works well. And I've had this particular one screwed to my fence for like 3 months now, and it stays at like 95% battery all the time. So.
What's the power draw?
Oh, very little. Someone told me that, but I don't remember. Do you have a multimeter?
Not on.
Yeah.
I draw the line somewhere.
That on your slide was 5 watts, and they usually way overestimate that. So less than 5 watts.
Yeah, I know that. So the like guide that I initially used that sized this was like estimating that these 2 batteries would be good for a month with no solar input. So it's really between this panel and these batteries, this is way overbuilt, which is pretty cool. Oh yeah, so
No current.
Oh okay. So I could just pass this around. I don't know, you can look at it. Just don't rip it apart.
Now we can make it a challenge.
But wait, there's more. Okay, so some of you were bored because there's no typing on the terminal happening in this talk. So we can talk about that. There is a Linux command line interface for this stuff. You don't have to use an Android app. You can use Linux command line to interact with your nodes. I'll say that it's not wonderful. Like probably if you're using the Linux CLI, it's because you have a lot of nodes and you're interested in like remote configuration. Like you want to like flash the node that is on the other side of the valley, like over the air or something. I guess that wouldn't work, but you could change configuration settings over the air through the Meshtastic.
I like the light pen graphic there.
Oh yeah, yeah.
That's awesome.
Okay, I think in the interest of time, I won't actually do the demo, but I'll just walk.
It doesn't look that complicated.
Yeah, it's not that complicated, but so you can make sure that you have, if you plug the thing into your computer, which like you can do with a USB-C cable, then you can say ls USB to make sure that the device is recognized. And then if you do Meshtastic no proto, it will just give you the equivalent of serial output. So that's useful for debugging. The rest of these commands are examples of what you can do over Bluetooth, so you don't need to plug it in. So you could connect to the node over Bluetooth, and you could scan for other nodes. You could get information. You can save your configuration out, which is pretty useful. And you can also do some like remote administration. So that's pretty neat. So you can change settings of nodes that might be multiple hops away.
So hang on, what's the FE 1932 DB? That's the
so
ID of the node?
Yeah, so these things have like a, what kind of appears like a MAC address.
Yeah.
And the identifier that gets used is like the last 8, hex digits of that.
What's the exclamation mark mean?
Some strange
Yeah.
part of this interface. You can also do 0x.
Gotcha.
That implies it's a hex.
Yeah, it is hex.
So there is no TNS equivalent.
No.
You get to
You can
get to identify people by their MAC address.
Yeah, so you can use.
I know some people would be thrilled by that.
Yeah, please. Clear. So you can refer to nodes by their name, like this. So here I have, this node is a zebra emoji.
Nice.
And so you can put a zebra emoji right there on the command line. You can do it. You might not want to.
Implementation of Unicode on the terminal is a dark day.
or a day of great brightness, depending on your perspective. Okay, there's also this app called MeshSense that these people at Firmatech have developed. I tried to use it. People seem to like it. I don't really get it. It does everything, all the same stuff the phone app does, but you should know that it exists and you run it on your computer. So I guess if you don't have a phone, you can use this. There are some resources you should know about. So if you go to pdxmesh.com, it will just redirect you to a Discord channel. And that's quite active. There's a lot of people on there. And so if you're thinking about getting into this and want to talk to other humans, you can do that through Discord. There are some local meetups, like this group Resiliency Portland had like a training at the Hollywood Library that I heard was pretty cool. I haven't connected with them, but it seems like they're doing good things and they're interested in resiliency, so that's cool. Here's where the software exists. It's on GitHub. That's probably not a great surprise. There's a ton of resources on YouTube. So if what you enjoy is like people talking at a camera to learn things, you can definitely do that. Among the ones that I've watched, which is not too many, I found this one to be quite good. So the comms channel, this was the person whose outdoor node I based mine off of. That's it. Yeah.
More questions?
I don't know if you are familiar with, like, can you speak a little bit at all about the, instead of going over Bluetooth, the wireless, over the Wi-Fi side of things? Because I'm assuming a lot of folks want to have like a device on the network. And I guess also talk about the web UI. I don't know if you're familiar.
Yeah, the web UI I tried to use, and again, sort of like the web flasher, I don't know how it works. It scares me. There's some kind. Do you know how that works?
Only at a very high level. There's a extension motor browsers that can do like USB serial pass through.
Yeah.
And
that's
those are
right.
just built into all the major browsers at this point.
Wow. Cool. Yeah.
And so you have to get permission to the browser to scan your USB devices, but there's a bunch of devices that can flash over your website now.
Yeah. So
including some stuff like OMG plug, stuff like that also does it.
Okay. Yeah. So I think it's client.meshtastic.org is like a browser-based client that will use this browser to serial interface and communicate with your device. That's kind of cool. My neighbor was trying to use it, and he said that like every time his browser window changed, it lost all the context for the conversation. Like there were things about it that he found pretty annoying. So the phone app was better in my experience. Your question about the Wi-Fi. So the only reason you would use Wi-Fi is if you wanted to do this MQTT bridging. So like if you live far away and you want your network to connect with like the larger Portland network, then what you would do is you would have two nodes, each of which has a LoRa radio and a Wi-Fi radio. And then what it'll do is it'll use that MQTT to tunnel the messages through the internet over Wi-Fi. Yeah.
If I may, I still haven't implemented this yet. I
Yeah.
purchased the hardware for this, but is it not possible to use the web UI to utilize multiple clients within the network? That was what I was thinking. So I'm
Yeah.
not. What I'm doing is basically got a PoE hat for
Okay.
a Pi Zero type device,
Mhm.
and then getting if I remember correctly, an SPI protocol radio, and then trying to tie that. I haven't implemented this yet, but that's the plan of this. And more than happy to share once I do have it done. But my understanding was it's feasible to
Bridge directly through that.
Yeah, so like if I want to send a message, I can send a message if my wife wants to send a message, because the idea is we have multiple households, the in-laws live on the west side, et cetera. Some earthquake happens, the wife moves out, the message is like if she's on the web, et cetera, et cetera. That's the idea. But again,
sounds super interesting. I have not approached or tried to solve that problem. So far, what I've done is have one device per person, one client, and a phone app because people find. But like the training the in-laws to use this that's a techno-social problem that I have not yet approached really.
And I'm not sure I would want to, I think it's probably more along the lines of here's the instructions, when the emergency comes, I'm sure you'll be sitting there doing nothing, so.
Yeah, I know, I guess I'm just, you hear these, this is the part of where we should turn off the recording. You hear these stories about ham folks saving the day, there was some, I can't think of a particular instance, but there've been several in the news where something happened and then somebody with a ham radio license sort of went out and saved the day. And it's like, well, that's pretty cool, but there aren't really that many hams.
Right.
And so I don't know if I want like my safety and all of my loved ones' safety to rely on the ham radio operators. Sorry, guys. So, you know, I don't know if I really hope in an emergency context that like all of my family is going to be successfully using this, but I'm hoping that I can like communicate with some other people that can get around.
No, absolutely. I don't think I have an expectation.
Yeah,
that
yeah.
They'll be, I think it's more like, oh, this would be nice to have, just to let them know that we're okay, or not okay,
Yeah.
whatever the case may be.
So,
Totally, yeah, I agree.
I've got a question.
Yeah.
So how do messages get stored? I mean,
Yeah.
say you're the recipient, the intended recipient for
Yeah.
some message that you sent. It's not, if it just scrolls off the screen, it's not very useful, because you're out, you know, digging your pit toilet in the side yard. You need it to like get logged somewhere, or at least like stored so that you can see the message, like, I've got 6 rolls of toilet paper, you know.
Yeah. So they have this buffer and they store a certain number of,
Yeah.
of nodes. But maybe this is a good, you know, sort of example of this point where it would be nice to have a continually connected like terminal or something. Because yeah, if you haven't connected to your node in quite a while and the messages have fallen off the buffer, you just won't get them.
You need like a hard copy terminal to like print out.
I knew you were going there.
Ticker tape?
Yeah.
From your old days.
Oh, my God. Oh, I gave away my serial .matrix spreader.
So I first heard about this last fall at DEF CON,
Cool.
where there was, you would see people wandering around with these all the time, and there was a lot. Someone brought it up and showed me the list of nodes, and there was a lot of them up.
Yeah.
It's taking off in that community a lot.
It's yeah, that doesn't surprise me, and I've heard about DEF CON as being like almost a, you know, like yes, people were getting into it, and that showed up at DEF CON, but then also more people got into it afterwards because they realized it was actually able to scale to that number of nodes in a small space. So it was a, you know, test of the technology in some
Stress
sense.
test.
Yeah, stress test term, yeah.
What, if any, concerns do you have about the anti-malware of the blobs you're shoving onto these nodes?
Oh, am I concerned that the firmware has some badness in it?
Yes. I bring this up because there was an example recently of, well, whether it was true or not, the very inexpensive NUC-like thing being sold, and someone who claimed to be a security researcher said there was so much state level badness on this thing that even I couldn't get rid of it all.
Huh. Well, this is the benefit of being open source, the, you know, Meshtastic. You can look. You can't look at something that isn't. But that's not to say that there's not still something in there. You know, but yeah, I think you have to trust. You have to suspend disbelief a little bit that the community, you know, the Linus's law, many eyes make all bugs shallow.
Yeah. Well, I mean, do you know, check the hash against what you're downloading when you download it and install it? How do you know the provenance of the blob that you've gotten?
I used to. To be totally honest, I absolutely used to, but we've probably all got a little lazier about that than we should be.
And I think, I mean, honestly, like that other example with the NUC, keep in mind that that's like an x86 device with the Windows running on it, and that's the reason why, is my understanding. And of course, that also probably has like a UEFI or whatever that has that capability. These things, you know, from factory.
Cortex M0 is not going to have
Yeah,
that
right,
problem.
exactly, right? Like the from the factory that comes like that, the chip is so tiny it can barely hold the firmware itself. Like it barely has that capability. So I think I'm not saying it's not possible, at a state level, actor level, threat level, they probably can figure it out, but what's the probability?
What can
Well,
they get from you
the
that they
stakes are
can't
pretty
get
low.
From
from
your
most of
cell
other
phone,
ways?
exactly.
I'd be more concerned about the LoRa radio
Well-
itself.
Yeah, precisely.
Immediate access into your network.
No, but that's what he's saying, is like, you can, like, your cell phone, your x86
Yeah.
computer has a higher probability
Right.
of being compromised than compared to something like this, which is, yeah.
Yeah.
It's still true.
These are good concerns, and it would be nice if the whole thing was open.
The weakest link is where you get attacked, so
Yeah. Any other?
don't put
questions?
your
Yeah,
dish,
go ahead.
don't put your washing machine on the net.
You might get your clothes washed, but you don't want
I
to.
want the Chinese government running
Yeah.
my clothes.
Yeah.
Oh, good. No.
There you go.
So, I want to send data over Meshtastic, right? I have a local node with some sensor on it, and I want
Oh,
to.
yeah, cool. Good question.
So is Meshtastic, you've got the little text protocol that's built into the phone thing, but there's other protocols built into that for data broadcast and things like that?
Yeah, there is a telemetry protocol, and so you can put sensors on these. So I think that one that was being passed around, I have like a temperature and a humidity sensor. And so, I don't know at what frequency, but the node just broadcasts a telemetry packet at some interval. And you can see that in the app. So when I'm connected to that node, I can go in and I can actually see a nice line plot of temperature and humidity. I think there are a lot of applications for using these devices with or without Meshtastic as sensing and telemetry nodes. The radio platform is pretty capable for that.
So you said the box would last about a month when the battery's gone.
Yeah, I don't know if
Okay.
that's right, but quite a
My
while.
calculations are correct, it draws about 50 milliwatts.
Oh, that sounds about right.
Average, I guess.
Yeah, someone told me how much it was during ascend, and I feel like it was almost
Obviously,
on
it's
that
higher-
scale.
higher
Well,
when
I
you're
think it
transmitting.
wasn't that much higher, but yeah.
Well, most people would be using their phones to interface with the device, probably be more concerned about their phone running out of power.
Yeah.
Yeah, can you charge your phone off?
I actually saw there's somebody on Etsy now that's making an enclosure that has the inductive charger built into it, so you could do the opposite. You could charge your Meshtastic device with your phone. It's kind of cool. Because you're going to chuck it in that emergency kit, and then who knows what its state's going to be.
The other kind of group of people, the DSA people, for example, part of their, I think, I haven't talked to any of them, but the sense you get is this is some sort of resilient communication that they're not gonna, but seems like governments could probably jam it pretty easily.
Oh yeah, well, I think it can certainly be jammed, and I think that it is, it could be used to track you. There's all sorts of, if somebody was, trying to use this against you or disrupt it, I don't think that would be.
Yeah, if
There
you're
are
producing
ways.
a signal, that signal can be followed.
Yeah. But, for now, it's not. I don't know, security through obscurity, a little bit.
There was somebody I was talking to who had gone to some meeting or presentation where there were some strategies to deal with that, like you throw a repeater on a roof and then you're not actually disclosing your location or whatever,
Yeah.
and you can relay through the local thing.
Yeah,
The local version of a proxy.
I guess so.
Yeah, when you're getting into a realm where a device built with a solar panel costs $100, you can almost have throwy devices, which is pretty interesting.
Has there been any work around the lifespan of one functioning in the field?
No, not that I'm aware of, but mine have been going for about 6 months and they seem to work great.
Probably the lifespan of the batteries.
Yeah.
Would be my first guess.
Yeah, the batteries are starting to degrade a little bit even on the one side. So,
Especially up on a roof.
yeah.
Oh, yeah, the temperature going up and down.
I mean, I have to wonder if, I mean, this seems most useful, say, like in a disaster situation. But, you know, our phones, they already have radios in them. I mean, let's just say that all the infrastructure is broken that, you know, for communicating with cell towers or whatever. Couldn't there be a protocol for just having the radios in our phones talk to each other?
There could be. However, the people
Act as
who.
a mesh?
But
who
then
write
you'd have to
the-
have Qualcomm.
The people who write the software for the phones are hostile to that idea.
Oh.
Because the carriers are hostile to that idea.
Well, I've already,
Oh,
already
yeah.
read that Verizon, somebody's is tying their phones into the Elon's, what you call it?
Starlink, yeah.
But then, you know, if you're gonna do something like that, you're gonna be beholden to some billionaire somewhere to
So
set up a satellite.
there was a guy in Australia who had a project called the Serval Project, and his idea was to use the Wi-Fi radios in cheap Android phones to do direct mesh networking. And Google just viciously removed every workaround they tried to do.
Phones are also not type certified by the FCC in the United States to broadcast on other frequencies other than those that are assigned.
Yeah, but Wi-Fi should work.
But Wi-Fi works,
Yeah.
Bluetooth
Well,
works,
it
but
does-
those are all part of the type certification for a cell phone.
You can't, well, anyway, the story was that Google kept removing the features that allowed you to
Correct.
do mesh networking.
Yeah.
Correct. And there actually is a software-defined radio in here, and you can modify it, but it gets into a legal gray area.
Right.
It's not part of the type certification for a cellular phone.
Question?
Going back to the sort of using it maybe to get sensor data transmitted, if you say you want data from somewhere very remote, backcountry or far away, what is the do we know, or the furthest distance between nodes you can actually get that?
Yeah, so I mean, there are people that get excited about doing the longest range test, and there's one that's, I think, over like the North Sea, you know, in Europe, Sweden, and you know, I don't know, they did like 150 kilometers or something, with, you know, effectively like a 5 dBi antenna. You know, I don't think they even had massive antennas, no amplifiers. So in free space, you can actually get pretty long distances. It's just if you're in the clutter of trees and you know, trees for the backcountry, or, you know, buildings for the built environment, then you're looking at more like a mile or two.
I think if you set it to a lower bit rate, it'll tolerate more noise.
Right.
And get a longer range by doing that.
Yeah, so the long fast is, I think, meant to be sort of a nice compromise, but you could go even slower.
How does it deal with collisions?
Oh,
It's just
it's just,
retries.
yeah, it's just
Yeah.
noise, yeah.
And if the network gets too dense, so there are lots of nodes between you and that, does that mean you just can't get that far?
Right.
Because the 6 is, so if everyone gets one of these, then you definitely can't do it.
Yeah, that's right. Actually, as the mesh grows in size, it reduces sort of the length. You know, this is like me trying to communicate with my buddy in Beaverton. It's like, I think there's a path, but he's just too many hops away.
Well, natural disaster will take care of that part of that.
Yeah.
So not everybody's gonna survive. They'll thin the nodes down a little bit.
That's true, yeah.
I know you showed about the QR code and sort of being able to ensconce like a subset of thing inside of an encrypted space, but like that doesn't change the fact that it's still saturating the network. So there's no difference it's not bouncing anything differently, because it's like, I know I can't read it, so I'm not gonna send it to all these people.
That's right. Yeah, there's no routing, so everybody just retransmits everything up to a point. And so, you know, I was actually looking up just before the meeting. You know, are there any other firmware, you know, like an alternative to Meshtastic that runs on these devices that does do routing, which is, you know, basically what you're referring to, this idea that you can choose which way to send the packet based on where it's destined. And I think that there are some other, you know, there's one called like Meshtastic LoRa, which is a very confusing name. But anyway, you could look into that. I think that's probably where the people in Portland need to go, because we're reaching a level of density. The issue is that, like, the reason this is so cool is working so well is because out of the box it just works. And so as soon as we make it more complicated, we're going to be back in that place of existential pain where we have not enough, we don't have a critical mass. Yeah, you got a couple over here. Yeah, how about you?
I don't really understand how, if there's a disaster, how this would be so much better than a ham radio. Is it that it's more portable, you need a license? Like what are some like really big?
It doesn't require the license.
Yeah.
So that right now, to be a ham radio operator, you have to pass a test. I don't think it's that arduous, but yeah, but not many people are doing it because people don't like tests.
So you feel people would be more likely to use this if they knew about it?
I think that there are probably already an order of magnitude more people using this than are ham licensed in the same area.
Ham radios are also more expensive. These are at $100.
Yeah.
Sorry, for a good quality ham radio. I know that there's some that are in the $20 to $50 range. I'm a ham for full disclosure.
I mean,
some of you know, some of you don't. So
Yeah, but you use a radio.
wow.
So
They don't call it Waldorf.
I could, yes. And it becomes an alternate way of communicating.
So would it be a good idea to have both?
Yes.
Okay.
I think that both are fun, right? I mean, when you talk about emergency preparedness, and that's super interesting, and that is why I got interested in it. But right now, we're okay, and it is just fun, too. So I think that both things are interesting to play with.
Does anybody use CD radios anymore?
If folks are interested in those sort of stuff, the PDX-NET, which is a kind of local volunteer group, they have a radio group, and they will train you if you sign up to be a volunteer with them. In cases of emergency, you're there with so different possibilities.
I love the idea of that feels very Portland, that we could have like a group of people doing CB in like Southeast or something.
Could you use one of those frequencies for,
for data,
data?
That's interesting. Does anyone know what the CB?
2027 was up on as one of the bands there. I suspect that may have been the old. That's the frequency.
That's CB 27 megahertz.
It's
Really?
around 27.
I think they took some of the channels and repurposed them, but I thought there were some left.
Yeah. Huh. I don't know the history of CB.
I have one
It's
in a
interesting.
closet somewhere.
Yeah.
Pull it out.
Ask the Oracle.
Yeah.
I'm sure it could tell you.
Okay, one final question. Yes.
Has anyone been crazy enough to try to tunnel IP packets through this?
Yeah, I know. I had the same thought, right? I don't know. It's a great question.
If they're crazy enough to do avian IP, I'm sure they've done it.
Take these
No,
packets.
they're other LoRa based.
Yeah, there you go.
LoRa man.
I mean,
Yeah.
nothing's stopping me from doing it other than security and speed.
So ham LoRa pigeons.
Yes.
Check.
LoRa.
Okay. Yeah.
Very cool.